Hello. Now we're going to continue our work in circles today, and we are looking at the interaction between straight lines and circles. So we're going to start off here, find the point of intersection between L and S, where L is given by the equation of the straight line and S is the equation of a circle. Anytime we're dealing with the intersection of something, we're always dealing with simultaneous equations. There's never an exception. And here I see that I have one linear and one quadratic, or one x squared and y squared type equation. So this is just the work that we would have done in algebra before. There's nothing different except that we are coming across it in the context of the circle chapter, but it is exactly the same maths. This is just simultaneous equations with one linear and one quadratic. So the method we know for that already, where we are going to substitute, we're going to rearrange our linear equation to get x is equal to or y is equal to, and substitute that into our quadratic equation and solve, is going to be how we're going to get our answers here. Now there's something else that we want to focus on if we saw this in an exam question, and that's to read the English carefully. Find the point of intersection between L and S. The point. There's only one. So if there's only one point of intersection between a line and a circle, what does that tell me about this line? It must be a tangent to my circle. It only touches the circle at one point. So if it had said the points of intersection, I'd know that I was dealing with something that crossed the circle at 2 points. 1, 2. In this case, I'm told that I am only going to touch the circle at 1 point. So it just touches off the circle at 1 point. That tells me that my line L is a tangent line. So now that I have that in my toolkit, what am I expecting to happen when I do the algebra of this situation? I'm expecting that I'm going to get a repeated root when I'm solving my quadratic equation, because I should only get one solution to my quadratic. But that's enough preamble. Let's get into how we would approach the question. As always, I'm going to recommend to you to draw a sketch, not necessarily in the exam, but for building up intuition now. Because if we draw sketches, we are going to have a much stronger sense of what's happening. And then when we come to the exam, we will be able to work with a mental image of what's going on. So I'm going to write down, this is in the expanded version of the equation of the circle, or formula for the circle. So I'm going to write down that formula and use it to figure out my G, F, and C. Most of the time in exam questions, you're going to need these letters anyway, so finding them for drawing a sketch isn't any hardship. We need to do it anyway. I can't see any X in this, which tells me that G must be 0. The coefficient in front of y is 6, so 2 times f, that means that f must be equal to half of that, which is 3, and c is just a constant on the end. That's my g, f, and c. What does that tell me? It tells me my center is at minus g and minus f. I get that from my log tables. It's important that we open up the log tables because the centers of our circle are different for the different versions of my circle equation. So it's important I write them down explicitly. And I know that OR is given to me by g squared plus f squared minus c. Subbing into that, I get 0 squared plus 3 squared minus 16. Don't forget to use your brackets to avoid mistakes with signs. And I end up with the square root of 25, which is 5. So I now know the general shape of my circle. Now let's get a better intuition for the equation of my line L. So I now know lots of things about S. Let's get to know L a little bit better. So I start off with 3x minus 4y plus 13 is equal to 0. Rearranging this equation, I will end up with y is equal to 3 over 4x. plus 13 all over 4. 13 all over 4 is equal to 3.25 for drawing and sketch purposes. So I now know all of the information I need to draw a quick sketch of my situation. So I draw this in. I know the center of my circle is at 0, minus 3. So 1, 2, 3. I know the center of my circle is there. I know its radius is 5. So if we start at minus 3, the radius is going to come up to 2 up here. So my circle is going to look something very approximately like that. And I know how I have a tangent with a, I know I have a tangent because I know I have a point of intersection. So I know I have a line that is going to just touch the circle that has a slope of 3 over 4 and crosses the y-axis at 3.25. So if I go up 1, 2, 3 and a bit, so I know that I have a line that is going to be going roughly in that direction, and I'm looking for this point of intersection here. So now I have a rough sketch of what it is I'm doing. Do I need to do that in the exam? No. Do I want to do it now to develop better intuition so I can do better in the exam? Yes. So now I have my setup done. I'm just going to do my simultaneous equations. So I have already, for doing my sketch, rearranged my linear equation, but I'm going to write this all over 4 because that is going to make my life easier for substituting into my quadratic. So again, for a linear and quadratic simultaneous equation, I rearrange the linear equation so that I can sub it in to the quadratic one. So I see that I have a y term here, and I also have a y squared term. Because this is such a large, messy thing already, I might actually square this out before I sub it in. So I'd be subbing in the y in here, and I'd be subbing in the y squared over here. So I'm actually going to square both sides of this so I know what the squared version of this looks like before I sub it in. This isn't necessary, but it's something that can help us to avoid making mistakes. So we end up with y squared is going to be equal to square the first by the second, and double it. Plus 78x plus 13 squared is 169. All over 4 squared is 16. So I now have my y term and I have my y squared term. I can now sub that into my quadratic equation. So when I do that, I'm going to write down my x squared. I'm going to rewrite the equation I am going to sub into so that I can keep better track of what it is I'm doing, because this is going to get messy for a minute now. So I have my x squared plus y. I'm subbing in from my linear equation. 9x squared plus 78x plus 169 all over 16 plus 6 times the y, which is 3x plus 13 all over 4 minus 16 is equal to 0. Now I need to turn this into something that's a little bit nicer to deal with. So what do I need to do? I want to get rid of these fractions. Fractions in equations are always a heartache. We want to get rid of them. So what's my lowest common denominator? My lowest common denominator is going to be 16. So I need to get everything over 16. So multiplying here by 16 all over 16, because this is over 1. This doesn't need anything done to it. This needs to be multiplied by 4 over 4. This needs to be multiplied by 16 over 16 because it's currently over 1. And I get everything over 16. All going to be over the same common denominator. So I get 16x squared plus 9x squared plus 78x plus 169 plus 24 on 3x plus 13 minus 16 by 16 is 256. All over 16 is equal to 0. I can now multiply both sides by 16 to get rid of this fraction, because now everything is over 16. So I can make both sides of my equation 16 times bigger. That gets rid of my fraction. I have 16 divided by 16 here. And I end up with my 16 plus 9 is 25x squared. I can mark all of my common terms. I can't add up these just yet, so I will leave that. 78x plus 169 plus 72x plus 312 minus 256 is equal to 0. Now I can add up all of my like terms. So I can put dots here, stars here. And when I do that, I get 25x squared plus 150x plus 225 is equal to 0. I recognize I have a common factor of 25 to all of these things. If I didn't recognize I had a common factor of 25, I could just divide by 5 and I'd see I'd be able to divide by 5 again. So don't worry if it's not obvious that there's a common factor of 25. So long as we get rid of our common factors, we can do it piecemeal. And I end up with x squared plus 6x plus 9 is equal to 0. What immediately jumps out at me about this equation, if I half the number in front of the x and then square it, so that would be 3. 3 squared is 9. This is a perfect square. So I should be able to spot perfect squares when they come up. So this is half of the coefficient of the x squared should give the number on the end. It's an important pattern to be able to spot. So this factorizes to 3x all squared. Therefore, x plus 3 is equal to 0. Therefore, x is equal to minus 3. Subtract 3 from both sides. Subbing that into my equation, a linear equation, I get y is equal to 3 over 4 x plus 13 all over 4. So is equal to 3 over 4 on minus 3 plus 13 all over 4. Ends up working out to 1. Therefore, my point of intersection, so L intersection S, is going to be equal to the coordinate minus 3, 1. Why did I only get 1 point? Because I have at 1 point of intersection, because I have a tangent to my circle. So once I knew that, I knew I was going to get a repeated root. And I can see that I did things correctly because I ended up with a repeated root and only